He does not take funds from the pharmaceutical company, so his research is independent. You need to look for independent research. Again, that's a side note there about the energy carried by the radiation. Microwave, they do carry radiation. Okay, so using this equation there, you can see based on the wavelength there, if you put a much bigger number here, you end up with lower energy. So microwave doesn't carry as much energy, but it is still a type of radiation. It is still strong enough to cook your food. So be careful next time when you use your cell phone, and try to avoid putting it too close to your body. And how far is the safe distance? How far away is the safe distance? Normally you can see the radiation, the wavelength for the microwave is 10 to the negative second meters. That's, we're talking about centimeters there. So about 50 centimeters away, that's a safe distance there. The next time when you use the microwave oven, you may want to step back a little bit and stay away from that radiation. Okay. Using these two equations there, well, mainly for this particular exercise there, using the first equation, we can ask you to calculate the frequency given the wavelength, and giving you the frequency, ask you to calculate the wavelength, and then giving you the wavelength and ask you to calculate the frequency. So all of these sample questions there uses the first equation there. And one thing you do need to remember is that these two numbers multiply by one another, you end up with the same, and you end up with the constant there. Okay, so try this, and I have several questions related to this particular equation in the homework assignments there. And so I want you to take your time and go through the calculation there. So those are the equations there. Now, another thing that you saw in the previous video is that when you have hydrogen gas trapped inside a glass tubing, when you pass electricity through it, you see what we call line emission spectrum. Okay? Each different element, atoms of each different element, will absorb that energy differently. As a result, they're going to give out different colored lines. And this is something that we can actually identify. We can actually use to identify the material. And one of the things that we can do is what we call the flame test. Okay. Now, one thing about the line emission spectrum there is that it's not continuous. With the visible light, if you pass the visible light through a spectrum there, you get a continuous spectrum, red all the way to blue, and there's a green and yellow in between. Okay? The line emission spectrum, however, when the element absorbs the energy, it gives out individual visible lines. They're not clustered together, separate lines there. So when you do flame tests there with different elements there, you end up with different colors. What's the relationship between the identity of the atom and the color that we see? Now, the flame test is something that we can do easily in the laboratory there. If you have a solution containing sodium chloride, you use the platinum wire and you dip that wire into the sodium chloride solution. When you move that wire over to the Bunsen burner there, you see a yellow flame. Whenever you see a yellow flame, with the flame test, and that indicates the presence of sodium ion in here. Potassium, lithium, barium, they all give you different colors. That's why when you do the 4th of July is coming up, when you see all those fireworks, different types of metal elements in there and giving you different colors there. Okay, so how do we explain the origin of the line emission spectrum? Well, Niels Bohr, a Danish physicist, actually proposed at the beginning of at the turn of the last century there, and people are trying to understand the basic structure. Now that we all know the basic structure of the atom, you have positive charge center, you have electrons circulating around the positive charge center. So this is a proposed planetary structure of the atom where the electrons will circulate around the positively charged center in defined orbits. They're not moving randomly to all different places there. Rather, they have a confined orbit. Okay, just like the solar system, you have the sun in the center. Mercury has its own orbit to circulate around the sun. Earth has its own orbit to circulate around the sun. They never run into each other. Let's hope they will never run into each other. Okay. Now, the distance between these planets from the sun is different from one another. And Niels Bohr proposed, well, it's just like the solar system there. Electrons, they have different amount of energy. As a result, they keep themselves away from the positively charged center at different distance. Okay? So in this particular model, the attractive electrostatic force of the electron and nucleus were balanced by, when you do a circulation motion there, circular motion there, you have what we call a centrifugal force. When you're circulating around a positively charged center, you are trying to get away. But because of the charges, positive charge in the center and negative charge on the electron, the centrifugal force is balanced by that, the attractive electrostatic force there. So when you look at the spectrum of white light, you end up with the continuous spectrum, okay? And when you look at the line emission spectrum hydrogen there, you see individual lines. And this is what we call the line emission spectrum. Now, our task is to figure out why and where does these lines come from? What's the relationship between the identity of the elements trapped inside this tube and the lines that we absorb in different regions? With different colors there, we now understand there's a different wavelength or frequency associated with it. Okay, so the line emission spectrum of the excited atoms there, well, excited atoms emit light of only certain wavelength. And that's what we call the line emission spectrum there. And the wavelength of the emitted light are unique to each individual. Now the application, as you may have guessed, hydrogen, mercury, neon, any elements will have a unique type of line emission spectrum. Okay. Based on the line emission spectrum, we can identify what kind of element is present. And you may ask the question, one of the videos says that we watched today, and we detect the presence of a particular molecule or elements in a couple of billion light years of. How do you do that? Line emission spectrum is one of the methods that we can use to identify what's in there, who's giving out this kind of emission. So if you have hydrogen, and in that, from that radiation there, well, you will be able to see this kind of pattern, line emission spectrum. So this is something that we can use to identify an element there. So for the line emission spectrum, in the visible region for the hydrogen atom there, we have red, we have green, we have blue. Okay? Now our task now is, why do we have these three different types of lines there? Well, the line emission spectrum goes by the atomic spectrum and the atomic structure proposed by Niels Bohr basically explains, well, we have confined orbits where the electrons are using them to circulate around the positively charged center. If you have an electron going from, say, a higher energy level back down to a lower energy level, energy will be emitted. And of course, this energy quantity, the quantity of the energy released by this particular motion or move is going to be different compared from the energy release from, say, another electron coming down from a lower energy level to an even lower energy level there. So these numbers there, the colors there, represent different amount of energy. So the orbits or the energy level are quantized. They are always in integer number. There is no level 1.5. Okay, so it's 1, 2, 3, starting with 1. N equals to 1, 2, 3, 4. All the way to infinity in theory. We don't really have to go all the way to infinity. And when you go n equals to 7, you pretty much cover all the elements that we know of in terms of electron distribution. Okay, so the lines or the color corresponded to the jumps or transition between the levels there. If you go from a higher energy level down to a lower